This will be the beginning of a tutorial series that helps you understand how to use the Mega Molecules Organic Chemistry Kit and some suggestions on how to put together molecules for some of the exercises that you will be doing in class and with homework. Just to give you a little bit of an idea of exactly what is in this molecules kit, you will have a variety of different atoms and bonds. The most common two atoms that you will be using are the black carbon atoms and the white hydrogen atoms. So with organic chemistry, we're talking about hydrocarbons most often, and then we'll be adding in some of the other elements like oxygen and nitrogen. So oxygen is red, nitrogen is blue, and then we also will have some of the halogens. So the halogens are represented by yellow, green, orange, and purple, and we'll add that in as we go. If you're ever unsure about what color a specific atom is, this table 1 will tell you. This is a model kit that contains some other atoms that may be like sulfur and phosphorus, but we won't use those very much. The bonds, a couple of them are gray. So we have the shortest one I typically use for attachments from carbon to hydrogen. The regular single bond, that's a little bit bigger, a little bit longer. And then the longest ones are for multiple bonds. So this one in particular, you can use 2 of these or 3 of these for making double and triple bonds. And we'll go through some examples just to show you how that works. Those gray bonds are very flexible, and these black ones are very rigid. So if you look at the difference, these are very flexible, which allows you to make a lot of different molecular shapes and ring sizes. And these are very limiting. When we are going to end up doing things like conformers, Newman projections, I like using these better because it allows for better rotation when you're looking at different rotations of the structures, for chair structures also. So that's when I'll be using the black ones most often. Putting a structure together is as simple as taking an atom and attaching bonds. When you are attaching hydrogen atoms, one thing I like to do, and you'll notice this, particularly in this bin, is that I have hydrogen atoms already attached to these smallest of bonds. And that's because when I think it's instructive, rather than connecting a bond and then connecting an atom, I have the hydrogens already attached. So if I want to make methane, which is CH4, I already have those together. So you don't have to do it that way, but the size of these bins sort of allows you to have at least a few of these atoms, these hydrogen atoms, already attached to the small bonds. And if you want to, you can keep a few of them attached to the larger ones. But my personal preference is when I'm putting together larger structures like this, I like to save the regular sized bonds, these two, for carbon-carbon or carbon-oxygen or carbon-nitrogen bonds. And then I like to leave the little ones for hydrogens. Now, one thing that's important is that you don't necessarily have to put the hydrogens on. If you're in a hurry and you want to just put together, say, ethane, and you want to see how it looks or how the bond is, something like this, where you have a carbon, single bond, and a carbon, you don't necessarily have to put in the hydrogen atoms or the bonds. One thing that you will get used to the more you listen to me in class is that we're not making Lewis structures here, so you don't have to include every bond. But sometimes it may benefit you if you're putting together a structure like this, or you are writing a structure out on your piece of paper or on your tablet for an assignment. You can include hydrogen atoms as much as you want. There's nothing against putting hydrogen atoms if it helps you complete a problem. One thing that I will add, not just hydrogen atoms, but if we were to look at a carbon-oxygen bond. So let's say that we put together a structure like methanol, where it's a carbon bond to an oxygen, and then we have hydrogens attached. These kits don't really signify anything like a lone pair. So there's no like lobe. Some model kits have a lobe that you can attach that shows a lone pair. What you are looking for is just a spot that does not have a bond. So an oxygen has 2 bonding spaces, and then it would have 2 lone pairs. So the 2 little spikes here that I have left without having a bond, those would be the lone pairs. So those are the basics of putting together a simple structure, an explanation of what the individual parts of the kit are. In subsequent videos, I'll show you how to create rings, how to use multiple bonds, and to use other atoms, and how to think more about lone pairs and so on. So we'll just end this one for now, and I'll see you in the next video.